And hello, welcome everyone to this video. In the last videos, I actually talk about a little bit. I was starting to talk a little bit about port numbers. Let me bring up GIMP. I was starting to talk a little bit about port numbers, and if you watch, if you're looking at the playlist as well, I encourage you to watch the last video where I talk a lot about Wireshark, where you will be able to have the tools to let me quit. That was Wireshark, but I'm not going to use that in this video. But Wireshark helps you to analyze the packets coming in and out of your computer. Excuse me. Wireshark helps you to analyze packets coming in and out of your computer, so that's very helpful. Okay, so what we're gonna do now is talk a little bit more about port numbers. And of course, yes, previously it was all about they are used in network address translation. Okay, but this is actually a secondary use of port numbers. It's not the primary use. Okay, this is a secondary use. Why are port numbers there in the first place? Okay, why are port numbers there in the first place? Okay, so I'm going to talk more about the purposes of port numbers here, and we'll be delving into something called the transport layer. Okay, so don't worry about it. Transport layer. What other layers we are talking about just yet? Let's talk about computers talking to one another, and then we'll kind of define some terminology from there. Okay, so we'll start proper. Okay, let me get my notes. Alright, so let's talk about our basic idea of networking. Okay, networking is basically the study of how computers talk to each other. Alright, so you have computer A and computer B. Okay, and in the last videos there was a very simplified version of networking, where computer A sends messages to computer B, or computer A sends messages to computer B, and all you had to define were the sending and receiving addresses, whether be it the MAC address or IP address. So once you define the sender and receiver MAC and IP address, generally speaking, you will know where to send messages to. You will know which computer, right? So MAC address, IP address, these things tell you which computer or which Wi-Fi card. Ethernet interface to send to. Okay, so it's, for more generic high-level view, it's which computer you want to send to. Okay, that's a very, very simple way of talking about it. But now we're going to go into more detail, right? Once the message reaches computer B, what is computer B supposed to do? All right, where does this data go? Does it go to your web browser? Does it go to your email application? Does it go to a download? Okay, we have not talked about this before. You need to learn to, or rather, you need to know. This computer B needs to know, right? Computer B needs to know which, okay, and this is very important, application or program needs to is receiving the data, right? So computer B needs to know where to send data packets from the internet to each application, right? Okay, so here is where port numbers come in. Okay, here's where the port numbers come in. So port numbers will help. All right, port numbers will help you in a sense when you have just one computer. You have one computer. All right, you have one computer, but you have many applications, and the applications use these port numbers, okay, to establish connections with the internet. So maybe port 80 all the way down to 65. Okay, 6500. Yeah, man, I used to be much better at this. Hold on. Okay, let me try one more time. 65000. I mean, there are about 65,000 available port numbers. That's actually 2 to the power 16. Okay, so like much like how DHCP assigns IP addresses to each MAC address. Okay, there will the port number also, it's like a sort of a parking lot, right? Okay, it's not always true that one application will use one specific port number, or one type of application will use one specific port number. Okay, it's not always true. Okay, but sometimes you do. Okay, port numbers are not reserved for applications, for application types in general, but you can have reserved, you can still have reserved lots or reserved port numbers. Okay, so that, again, I like to use the analogy of parking lots. Okay, parking lots, generally speaking, you yeah, it could be a not so good analogy, but at least it tries. I'll try to simplify. Okay, so yeah, parking lots, these are ways for yeah, these are places for cars to park. Of course, there are some reserved lots which you can have for VIPs and all, but generally speaking, it's not for everyone. Okay, I mean, generally speaking, parking lots are not always reserved. Okay, another analogy is travel lanes. Okay, sometimes there are when you enter a country after you fly, or okay, when you enter a country after you fly, there are some places in the where you have express checkout or something like that. So I guess these are similar ways that ports work. These are just channels for your data to flow through. Okay, that's why they're called ports. Okay, or you can import or export data. These are ports, you know. So these are places, these are numbers or places, so to speak, if you want to think about places where your applications can import and export data. Some ports are reserved for like VIP applications, so you can send and receive data from that port. Okay, for example, port 80 tends to be a HTTP protocol. Okay, used for web traffic, and HTTPS is another port number, right? I guess that's homework for you. You can go to check out Wireshark to see or you can search Google to see what HTTPS port number is. Okay, different applications have different port numbers. Okay, and yeah, so they're not always reserved in general. Sometimes the same application can use different port numbers, especially if you're on the so-called client computer. Okay, but don't worry about client and server yet. If the time comes, then I'll introduce it to you. If not, I'll just leave it out, because I don't want to introduce too many new terms in one video. Okay. Okay. Alright, so let me delete this. Okay. So yeah, the port number will help us to know which application to send the data to. And actually, more accurately, it is about this thing called sockets. Okay, but let me explain. Yeah, when you come across networking, you will come across this term called sockets, right? You'll come across this term called sockets. Okay, so what's the idea of a socket? Okay, so let's say you have an app or program. Okay, app or program. and I assume you don't have too much programming knowledge at this point, or you're an amateur. All right. So normally when you when you have app or programs, at least in the old days, none of them will actually connect to the internet. All right. So for example, you have things like Notepad, right? Oh, I don't have Notepad here. Okay. So you have things like okay, maybe a writer, okay, like LibreOffice or Microsoft Word, but I prefer free things, so I'll just go with the LibreOffice example. Okay, you have LibreOffice here. You can type A, B, C, D, E, F, G, right, and then you just save. Okay, that's what the application does. Normally, there's no way for programs like this to connect to the computer. At least the old versions anyway. The new versions can have no file syncing, save into the network or whatever. So these are programs with internet connectivity. But in the old days, or rather generally speaking, unless you program it in, your app or program will not have internet connectivity. How will the program connect to the internet? Alright, it needs to get plugged in, right? So that's why I guess people use the term socket. So a socket is a part of the program or code which connects it to the internet. Okay, so that's a very layman. Of course, you can look for official definitions online. Let me go and show you. All right. So according to geeksforgeeks, a socket is an endpoint of a two-way communication link between two programs running on the network. Okay. So let's compare that with the definition. Well, yeah, the definition I have here is pretty loose. I guess it's a part of the program or code which connects it to the internet. Okay, this is the more accurate definition. It's one endpoint of a two-way communication link. Okay, so a socket is the endpoint of a communication link. So that's I guess a more refined part. You see, part of the program. Okay, we'll just call it an endpoint. Okay, the official term is called endpoint of a two-way com link. Okay, communication link, right? Which connects it to the internet, and not just any part of the internet. Well, you want to connect it to another program on the internet, right? Another program on another computer on the internet, right? So I have given you the very general definition just to give you an idea of what a socket does, and how it helps you connect to the internet, right? So what a socket will do, okay, a socket will, if you want to use that term, you'll plug into a specific port number, right? You'll plug in, yeah. It will plug in, okay, plug in to a specific port number. Okay, again, the port number can be a specialized port number, or it can be one selected at random. So what does the program do? What does the socket do? Okay, all right, so remember last time when we crafted messages, there's a Ethernet header, the Ethernet header that goes for the network layer model, our network layer. Then you have the internet layer, which is your IP protocols here. Okay, and then usually we will just call this okay, we'll have tail ends as well, of course, but very small bits of it will be at the tail end. Okay, so this is the header and the tail, the head and the tail, so to speak. And actually, when we talked about this IP payload, data payload, we didn't talk about the contents. Okay, so we have this Ethernet layer, we have this IP layer, which has this Ethernet layer has a source and destination MAC address. So this is to do with MAC address. Then we have the IP part, which talks about the IP address. Okay, IP address. Then you have one more layer down, and this is what we call, okay, this is where we have our transport layer. Okay, why is it called transport layer? Because I guess it's responsible for transporting data from one application on one computer to another application on another computer. So these two first layers, they are the data link layer and the network layer respectively. The transport layer is talking about app to app communication, app to app, or program to program, or program to app. So these are two different applications or programs on the computer talking to each other. So the transport layer helps to help you figure out the traffic using these port numbers, right? So it's not all messages going to one computer, they are stuck on the same program, right? They are on different programs. So this is what the transport layer does, okay? So that when messages come to the computer, you know which application to send it to, right? So this is the data link layer. The first tick is the data link layer. The second tick is the IP layer, or the networking layer, sorry. Third tick here is a transport layer, which talks about application to application communication. So it's very important because it will help us to filter which signals actually come from one application or another application. Okay, so this is what the transport layer does. It helps applications on individual computers talk to applications on other computers. That's the idea. The how you do it, yeah, there's a lot of things, but I just tell you why it's there and why these port numbers are here. All right. Okay, so if you can think about it like this, you have again, I will say computer A and computer B. Okay, again, they're talking to each other, or rather, if you want to go into more detail of what's actually happening, it's one application on computer B, computer A, sorry, this is computer A, and this is computer B. Okay, one application on computer A talking to another application on computer B. Alright, so it send and receive messages from each other like that. Alright, so between computer A and computer B, you will have all these IP packages and everything. But before that even, usually when the message is being crafted in computer A, you will have a source and destination port numbers. Source port and destination port. Okay, so this is the first part of the message, which goes into this transport layer message, which will serve as the data payload in this IP datagram. Okay, so all this source and destination port, all this information will be encapsulated. That means there will be we like to call it encapsulation because there is a header, there is a head and a tail. So you kind of package the data in some wrapping. So this is the IP wrapping, and then this is the Ethernet wrapping. So we call the wrapping encapsulation, right? So we encapsulate the data. Okay. Now, the picture is this. We don't only have one what do you call it? Okay, we don't only have one application talking to one application like that. Of course, the real life picture is it's more complicated. So in fact, we don't just have one application. We maybe have 4 or more, 5. I don't know how many applications you open. Okay, and maybe you have another 4 or 5 applications here. Okay, and all of them have to share the same Ethernet cable, right? So I have to send all the data from each application. They will probably use different port numbers, of course, but they have to have the same IP address and same MAC address, right? The same all these applications over here have the same IP address and the same MAC address. So in fact, we are actually combining a lot of these signals into one channel, right? We are combining a lot of signals into one channel. So this is called multiplexing. Okay, multiplexing, right? So we combine a lot of signals into one channel, and the channel means that, okay, I have the same IP and MAC address, and I have the same destination, source and destination IP address, and the same source and destination MAC address, at least for this example. Okay, and then when these signals are all on this same channel, okay, they're all on the same channel, and then when the computer B receives it, it needs to know which message goes to which application. So the act of splitting one complex signal into many so-called complex signals, this is called demultiplexing, which happens at computer B. Demultiplexing. Alright, so yeah, so this is the idea of multiplexing and demultiplexing. This is the picture you see. However, of course, again, the official definition of multiplexing and demultiplexing, it may confuse you at first, but it more or less corresponds to the way we are seeing multiplexing and demultiplexing like this. Okay, so multiplexing is, you can see, gathering data from multiple application processes of the sender, enveloping that data with a header, okay, and sending them as a whole. Okay, so remember the idea of combining multiple packets from multiple applications to make them share the same IP and MAC source address. Okay, that's called multiplexing. Of course, you have to define what's the address as well. Destination address. Okay, so that has to be done. And remember this idea of encapsulation here. It means that we have our application data, which is part of the transport layer. You need to know what port numbers and of course whatever application data you need. Then you need to encapsulate that, right? We like to use the term encapsulation because you have to add in information about the IP addresses. So you encapsulate that in your IP network kind of thing. So, and then furthermore, you need to encapsulate it with an Ethernet layer protocol for your MAC addresses. So that's what multiplexing is about. Okay, but just something to clarify here. You can see here that this definition says that we are gathering data from multiple application process of the sender and enveloping that data with a header. So when I read this first, yeah. Okay, just want to clear up some confusion. Okay, when I read this first, I thought that you will have multiple data pieces from different application in this same data payload in your IP datagram or your Ethernet frame. Okay, in your networking payload or whatever, I thought that you will have multiple data from different applications in the same packet. Okay, does that happen that way? No, not necessarily. If you check Wireshark, you will see that you rarely or ever it won't happen like that, because data packets are small, and data packets are small. So normally, even for one message from one application to another, it has to be broken up into many different data packets. So one email may have many data packets, for example. So it doesn't make sense for data from multiple applications to be bundled within the same data packet. No, doesn't usually happen, as far as I observe from my Wireshark kind of things. Okay, so anyway, the idea here, the most important idea here is that for multiplexing is that you envelop the data with a header. That's when multiplexing officially occurs. So the moment you cover up this how do you say? The moment you take your application data and you cover it up, you encapsulate it with your port numbers, your IP addresses, your MAC addresses, that is known as multiplexing. So this is where all the stuff is done. And then when it comes to the other side, you have this thing called demultiplexing, which is the most very important, delivering received segments at the receiver side to the correct application layer. So as you can see, we are delivering okay, the computer will analyze the port numbers once it receives the message, and then it will deliver it to the correct applications. All right, based on however you set up your socket. Yeah, this okay, the socket will help, is where you actually program in all your port numbers. And if you are interested in socket programming, you can take a look at this website here, socket programming in Python. Okay, I myself, as of the creation of this video, I have not learned how to do socket programming as well, but the general idea is there. Okay, and I saw that you will usually specify your port numbers over here. Okay, which port numbers to use. So again, multiplexing is okay when you combine several signals into one, okay, into one channel, and this channel, by channel I mean it has the same IP address and it's originating from the same IP address and the same MAC address. That's why the moment you how you do it actually is, of course, not just you don't just send data through the port, Ethernet port and everything. You got to make sure all the from the source addresses are right, i.e. the Ethernet address and the IP address. Okay, I mean the MAC address and the IP address, they all must be correct. So the moment you encapsulate your data with that, then you have effectively multiplexed your data. Okay, even though you don't exactly combine data from different applications in the same Ethernet frame or the same data packet, that doesn't really happen. Instead, it's just causing all of these data packets to share the same channel or share the same IP source and source IP address and source MAC address. So that's what multiplexing is about. And demultiplexing, okay, I read the port number and I send it to the right application. Okay, so this is why we have port numbers in the first place, is to help programs have the sufficient data to talk to each other. So you don't just need to know where to send your data packet to, which computer to send it to, you need to know which application. Okay, and to know which application to send your data to, you use this thing called port numbers. Okay, and how do you know which port number goes to which application? That is really up to you to program in your socket. And I guess this is part of how you program applications. It may be part of application layer. I don't recall now. I don't know. Well, I think technically sockets are not part of so I don't think they are exactly part of application layer. Application layer is for the end user to communicate with the program. Yeah, so that's why you have other things there as well, which make it easy for the end user to use the internet, or at least use the internet to do communication. However, sockets are definitely part of your application or program. You have to write them in yourself as a function or whatever in object-oriented programming. Okay, so hopefully this demystifies the whole what port numbers are there for. Okay, why are port numbers there in the first place? Of course, you use them in network address translation, but the primary use is to help applications talk to each other, and this is done in the process of multiplexing and demultiplexing. Okay, we've briefly gone through what encapsulation is about. Hopefully that is a recap, but I'm really explicitly saying it more in this video. We talked about port numbers, we talked about applications and sockets, and we talked about multiplexing and demultiplexing. So we covered a fair bit of concepts here, but hopefully it's not too technical for you if you're watching this as a non-professional. Okay, thanks for watching. I'll see you again.